Okay, so this is NEOCP object A10a3S1, and we have a number of images here that were taken to acquire this object. They're each 27 seconds in duration for a total elapsed time of about 15 minutes. So the goal of this video is to try and see if we can use the Tycho software to track this object and then take measurements of it. So to start off with, we have a star subtraction threshold, and you'll notice that there's a considerable amount of vignetting, which means for our purposes that we won't be using quite as much thresholding as we might ordinarily use, in case the object were to be located near the corners. So anyway, I'm using a value of 1200 here, and for the sensitivity threshold I'm going to use a value of 15. And finally, for these parameters, again, you can consult the wizard if you're not sure what to plug in, so that's just what I've done here. I put in the value of 6 for the start, 78 for stop, and then the step size of 0.04 is fine for this data set. So the next thing you can do, because this is a NEOCP object, is the position angle is generally known to some degree, so you can limit the PA range, which what that does is it limits the number of motion vectors that have to be processed. So if I uncheck that, you can see that there's a lot more motion vectors to go through. But this just makes it a lot quicker. So I'm going to go ahead and click OK, and as you notice, it already jumped up to 60% just about, and again, that's just because we narrowed down the search range using that limit PA option. So okay, it's just about finished, and okay, so it took 18 seconds, and as you can see, it is in fact object number 1 in the list of tracks. So I click on object number 1, and you can see in the image viewer, if I go from image to image, then you can see the object. So I'm zoomed in by a factor of 4 here. If I zoom out, you can also see it. So it did happen to be located somewhat near the corners, and so it's a good thing we didn't use quite as much thresholding. But in any case, there's the object. So the next question is, then can we go ahead and take some decent measurements of it? So first thing we do is we load up the star catalog. So we do that, and then I'm going to go ahead and for my first observation, my first measurement, I'm going to go ahead and stack all the images, and that's going to give me a nice centroid. So I'm going to double click create an observation, and that's my first one. So basically what I've done is that, again, I've stacked all the images relative to image 0, and what that does is give a very nice signal noise ratio. In other words, a much better centroid than we would otherwise have without stacking them. So that, as you can see, that's image, the first image without stacking, and then so forth. So all right, most of you are already familiar with that. So so my second observation, I'll do a similar thing and create observations. So now I have 2, and I'll create one more, and let's go ahead and see. So with these 3 observations, I can go ahead and copy them into the online find orb and see what kind of residuals we get. So if I paste them in here, it's going to come back and it says mean residual 0.25 arcseconds, which is actually quite good, considering that the plate scale that we're working at is 3.87 arcseconds per pixel. So I consider that to be a very good measurement, set of measurements. And so that about wraps it up for this particular video. Again, this is the Tycho software, and if you're interested in trying it out, let me know. And certainly if you run into any issues, I am more than happy to help. So thanks for watching.